One of the biggest scientific pursuits of recent times has been looking for signs of life in the solar system. And for scientists searching for alien life forms, the siren song of Mars is climbing toward a crescendo. Multiple recent observations made by rovers on the red planet could bear the signatures of microbes, a possible indication that Earth is not the only refuge for life in the solar system. Let's look at some of the findings NASA's Perseverance rover has recently made that may point towards the existence of life on the red planet. Did life ever arise on Mars? For years, NASA's Mars exploration program has been systematically trying to find out. The agency's Spirit and Opportunity rovers showed that liquid water once existed on the surface. Building on that discovery, NASA's Curiosity rover found conditions on Mars around 4 billion years ago that could have supported life as we know it. Now, Perseverance continues to directly search for signs of past life. Perseverance launched on July 30th, 2020, amidst the added challenge of the global COVID-19 pandemic. On February 18th, 2021, it landed in Jezero Crater, the site of an ancient lake and river delta. There, the rover has been searching for microbial fossils and rocks that formed in Mars's warm, wet past. It also looks for carbon-containing molecules called organics that form the building blocks of life on Earth. Not since 1976 has NASA directly searched for life on Mars, when the dual Viking landers performed long-shot chemistry experiments that turned up inconclusive results. Perseverance is collecting soil and rock samples as it travels, keeping them in tubes that future missions by NASA and the European Space Agency will collect. The 1-ton, 6-wheeled Mars rover is the size of a compact car. Based on the same design as nuclear-powered Curiosity, Perseverance can operate through dust storms that block sunlight required by solar-powered spacecraft. Using images from navigation cameras placed strategically around the rover, as well as imagery from orbital satellites such as NASA's Mars Reconnaissance Orbiter, scientists and mission operators work together to drive Perseverance to promising areas of interest. If a spot seems particularly interesting, the rover collects a sample, seals it in a small tube, and leaves the tube on the surface for return to Earth. Perseverance is the first NASA rover sent to search for signs of ancient life. Nearly a half-century ago, NASA sent a pair of landers to Mars, marking the first U.S. mission to successfully touch down on the planet. The Viking mission, launched in 1975, aimed to look for current life on Mars, and came up empty. The results from the Viking landers were ambiguous and taught us that we needed to better understand the surface of Mars and potential habitats on Mars. Follow-up missions of orbiters, landers, and rovers looked to see if Mars was even habitable to begin with. They focused on searching first for signs of ancient water, a key to life as we know it here on Earth. Rovers like Spirit and Opportunity launched in 2003, and Curiosity launched in 2011, provided the groundwork for Perseverance to begin searching for ancient microbes in the rocks and dirt on the planet. The rover is searching an area on Mars known as the Jezero Crater. Scientists think this might have been an ancient lake fed by a flow of Martian rivers. Over the next few months, the rover will make a beeline toward a river delta at the edge of the crater. Life as we know it requires habitable environments. The assumption is that life on Mars would need water as a universal solvent, much like life here on Earth. Finding environments where we know water may have once flowed is one of the biggest objectives for scientists to start digging deeper into the search for life. Much like river deltas here on Earth, scientists expect to find layers and layers of rich geological history trapped in the sediment, a prime spot for drilling samples that might have trapped evidence of past Martian life. Confirming ancient life on another planet would be an extraordinary finding. Experts say one that will require extraordinary evidence. The rover is equipped with drills and sample tubes and has already begun collecting bits of Martian rock. In its first year, it has collected and stashed 6 samples with the opportunity to collect up to 40. Perseverance has 2 main mission goals: search for signs of ancient life on Mars and collect the material for humanity's first Mars sample return effort. Towards this latter end, the rover carries 43 titanium tubes, 6 of which it has sealed to date. 4 of the sealed tubes contain cored rock samples, 1 has a sample of Martian atmosphere, and 1 harbors witness material to help mission team members spot any contaminating compounds that Perseverance might have brought from Earth. Perseverance spent its first few months on Mars, checking out its instruments and systems and supporting the initial pioneering flights of the Ingenuity helicopter, which landed with the rover. Perseverance began focusing on its science goals in early June of 2021, and it has made quite a bit of progress since then. The Sherlock instrument aboard the rover identified organics in the interiors of some rocks that it abraded with its drill, and also in the dust on top of some non-abraded rocks. Another Perseverance instrument, Pixel, is bringing that ancient environment into clearer focus as well. Pixel analyses of an abraded rock in a patch of Jezero called South Seta revealed a striking abundance of olivine crystals in conjunction with pyroxene crystals. This points towards the presence of volcanic activity on the Martian surface sometime in its past. Perseverance was also able to identify carbon-containing organic chemicals in some rocks from the Jezero crater on Mars. While this does not mean that life on Mars has been found, it points to the potential of past life on Mars. This is a question that may not be solved until the samples are returned to Earth, but the preservation of organics is very exciting. Once these samples are returned to Earth, they will be extensively studied for several years in an attempt to decode more about the mysterious red planet. While scientists wait for Perseverance to collect Martian samples, the mission is breaking ground in other ways. A tiny helicopter stowed away on the belly of the rover has completed 19 successful flights on the surface of Mars. What started as a proof of concept with major challenges, if engineers could even design an aircraft that could fly in Mars' thin atmosphere, is now helping the rover spot new places to explore. The helicopter can fly over areas that are too rugged for the rover to traverse. Scientists can see these high-resolution images in areas the rover can't reach, and thinking forward to maybe future exploration. Ingenuity is helping navigate Perseverance to that key target, another geologically rich river delta where scientists hope to peel back layers of Martian history written in the rocks by ancient water. Over the next several months, Perseverance will make its way there, with Ingenuity hopping along ahead to scope out the path. Perseverance is also the first Mars rover to use ground-penetrating radar. The RIMFAX, which is the radar imager for Mars subsurface experiment, creates a radargram of subsurface features up to about 33 feet deep. Perseverance obtained the first radargram at a ridgeline between the Crater Floor Fractured Rough Geologic Unit and the Seta Geologic Unit. The data show that multiple rock formations below the surface all have the same angle of tilt. The Seta rock layers also project below those of the crater floor fractured rough. This implies that Seta was formed before crater floor fractured rough. The rover is also helping plan for future human missions to Mars, like taking fabric samples that could one day be used for Mars-bound astronaut suits and exposing them to the planet's harsh atmosphere. Another experiment, called MOXIE, is working to convert that atmosphere into oxygen that could potentially be used for fuel or life support, pure enough to breathe. As it makes its way through the sediment-rich river delta of the Jezero crater, Perseverance is sending back stunning images of its new home on Mars. The rover is putting a lot of ground under its 6 wheels thanks to rugged new tires and a self-driving computer. The rover pretty much drives itself at blazing speeds, at least for a robot. But the state-of-the-art rover, which has traveled a few miles already, will have plenty more exploring to do to catch up with its predecessors. Curiosity has covered nearly 17 miles on the Martian surface, while Opportunity covered more than 28 miles before reaching its final resting place, Perseverance Valley. The Perseverance has already spent a year on the Martian surface and shows no signs of slowing down. While the rover has run into its fair share of trouble, which includes problems with its wheels and drilling equipment, thankfully scientists here on Earth were able to solve these problems without incident. Throughout its mission, the rover is expected to make more stunning discoveries about the red planet, which may come in handy if a manned mission to Mars ever comes to fruition. If you enjoyed today's video, please check out this one on how Elon Musk plans to colonize Mars in the near future. Do you think the rover will fulfill its mission and find definitive proof of life on Mars? Please share your thoughts in the comments section below.